S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Now, in order to describe the output value from the binary operations on the Boolean algebra, so some gates are defined. That gates are known as the logic gates.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box.
So myself, Dr. Narinder Kaur, welcome to S. Chan Academy. Let us begin how the binary system or the Boolean algebra that is implemented in the logical gates and how we can get the output value in the form of truth tables. So now what are the logic gates? Basically logic gates, these are the important digital devices that are mainly based on the Boolean function. So Boolean functions are either the different input or the variables value that can be add up, they can be multiplied or they can be subtracted. So depending upon the different Boolean functions, the different logic gates or the digital devices that can be designed. So logic gates, these are basically digital devices over here. The logical gates, they are used to carry out logic operations on a single or the multiple binary inputs. That means inputs that can be single or that can be in the multiple forms, and they will give one binary output. So that means only one truth table that can represent only one gate. So that is known as the digital devices of the logic gates. In simple terms, logical gates, these are the electronic circuits in the digital system. So that means in any digital system, all the analog signals that can be converted into the digital signals by using the Boolean algebra, and that Boolean algebra or the binary devices, they represent in terms of some devices, they are known as the logic gates over here. So now the basic logic gates, they are known as the OR gate, AND gate, NOT and the XOR gate. Additionally, when we are combining one or the two gates with each other, so we can get the NAND gate, NOR gate and the XOR gate and XOR gate. So these are the different kind of the logic gates, while the basic logic gates, these are the four logic gates over here. One is OR gate, AND, NOT and XOR gate. Now in these different logical gates, the different inputs are given and output that can be obtained in terms of the digital words, and the digital systems or the digital operators are there only 1 and 0. That means in terms of Boolean algebra, we are getting the output value over here. So on the different ports, we can give the input, but in the output, we can get either when there is a true, or we can get when the output is present, we can get only 1. And when there is no signal, no output is there, we are getting 0 only. So that means in the truth table, we are seeing only 1 or 0 is there. So these are the basically logic gates, these are the digital devices over here. So that means we are here taking the different input values, and on that input values, we are applying some logical operations. That operations that can be either addition of that inputs, that can be subtraction of the inputs, multiplication of the inputs, or combination of these two. So depending upon that or the logical operations, the different logical gates that can be designed. So now first one is the OR gate. So what does it mean? So OR gate, that is in an OR gate, the output of OR gate that attains the state 1 if one or more inputs attain the state 1. That means, now this is a symbol of basically OR gate. So in the OR gate, the Boolean algebra is like that, y that is equals to a plus b. So output that can be read as a or b. So because this is the OR gate, we are only saying that a or b, and this gate that can be represented like this. Now if there are the two input ports are present, A and B, and Y is here, so that is a mathematical or the Boolean expression for the given gate. So this kind of gate, that is known as a OR gate. So Y, that is read as A or B. So that means when we are giving input as 1 on either of them, either on A or on B or both of them, we are getting output on this this Y port. That means we are getting output is always present when there is one value is in the output, when there is output either on A or on B. So that is known as the OR gate. So it is represented like this over here. Now the truth table of this two OR gate that can be given as. Now when there is no input on the A and the B. So A and B, when they both are having the 0, then Y that will be equals to 0 over here. Now when there is 0 on A, there is no input in this port, and we are getting or giving the input only at the B, and the output we will get a 1 over here. So that means when the light is blowing or the light is given on the B port, we are getting a light over here. So 1 is there. Again, when there is input on the A port and no input on the B port, again we are getting a output on the Y port. Again, when there is input on the one port, A port, and input is also given on the A port, that means we are getting output on the Y port, but mathematically it is quite different. So in this case, that means when mathematically we are adding these two terms, so here when 1 is given over here and 1 is also over there, mathematically when we sum up these two terms, we will get over here 2. But in the logical gates, when the input is given in the 1 and also input is given in the B port, so in the Y port we are getting only 1 is there. So that means when the input is present on this port, the light is present on one port and the light is present on the second port, and we are getting a light in the output port. So this, when we understand this in terms of the light, so that means the Boolean or the digital signals, they can be better understand by taking the signals or the input value as a light. That means when the light is present on A, the light is present on B, and we are getting a light on the Y port. But in mathematically, when 1 is there, 1 is there, and when we add up these two, we will get the 2 over here. So this is the OR gate, and this is a representation of the OR gate. So that is the truth table of the OR gate. Now next is the AND gate. How we can represent the AND gate? So in the AND gate, the output of AND gate that attains 1 if and only if all the inputs are 1. That means if either of them that is equals to 1, we are not getting any output. When the output is given on the A, input is given on the A port and input is given on the B port, in that case we are getting output on the B port. So how we can write this as? So AND gate that can be represented like this. So these are the two ports over here, which is known as the input ports, and that is the output port. And that is read as Y, A and B. So that's why that is known as the AND gate. So Y output that is equals to A and B, and which is known as the AND gate over here. Now when we are giving the, how we can maintain this truth table. So in a truth table, if this is A and that is B and that is a Y output is there. Now when input is given on 1 and there is no input on the B. So what does it mean? In the AND gate, we are getting only the output when both of them having the input. Otherwise, we are not getting any output. Or mathematically, you can also correlate this. When you multiply 1 with 0, you will get 0. So that is also in the same value as that of mathematically. And when 0 is here, 1 is here, we are getting 0 over here. In the same way, when there is no input in both the ports, we are not getting any output. Now when 1 is, that means signal is given over here, and there is also signal on the B, and we are getting signal on the Y also. So in the Y port, signal is also present. So this is known as the AND gate, and that is read only as A and B. Now what is the difference between OR gate and AND gate? Now this is a truth table for A, and this is read as Y, that is equals to A and B. Now what is the difference between OR gate and AND gate? So now in the OR gate, the output that is given as A or B. So this is firstly the difference in the output value. So that is read as A or and B, and that is A or B. And in this case, we are always getting a output value when the signal is present in so that means in 1, if there is no input, then we are getting no input over here. When 1 is given, now in the output value, you can clearly see that when in some of the signals or when in some of the digital devices or the digital circuits, when we want to get the output value by giving only input to the one port, then in that case only OR gates they are preferred, because in the OR gate you can clearly see that when there is input on either one of the port, we are getting a output value. So that is the output value, that is 1 is always present in the 3 ones, while in this case when there is no input, we are not getting any input. So that means the OR gates, they are preferred in the digital circuits when we want to get an output value. That means when we want the output must be there. So we are getting only the 2 values and the output is present. In that case, we prefer only the OR gate. While when we need inverse, that means in some of the circuits, when we need only no output will be there. That means when we want to cut off the input and there is no output, in that case AND gate is preferred. So because in the AND gate, we are only getting output in one case, when we are giving input to the 2 ports. So that means it depends upon a requirement of the digital circuits. When we want to get an output value, that means when we want to enhance the signals, in that case OR gate is preferred, and we want the signals, the output of the signals that cannot be enhanced, and we want to get only the output once, or we want the input value, the input signals that is cut off, in that case AND gates preferred over here. So now let us take a break. So after the break, we will study the OR different types of the logic gates, which is NOR gate and the XOR gate.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. So now till now we have understood what are the logical gates, how the binary inputs that can be used in order to make the digital circuits or the digital devices, which these digital devices, they are known as the logical gates. And in the OR gate and the AND gate, in the AND gate we are getting the only output once, that is equals to 1, while in case of AND gate, OR gate, we are getting output on the 3 ports. That means when we need the output value will be there for the larger times, then in that case OR gate is preferred, otherwise AND gate is preferred. Now the next logical gate, that is known as the NOT gate. So in the NOT gate, the output of a NOT gate that attains state 1 if and only if the input does not attain state 1. So that means it will give the inverse over here. So in this case, NOT gate, the Boolean expression that is y equals to A inverse. What does it mean? So output that is known as A inverse over here. So inverse to the input, we are getting only output over here. So that type of gate, that is known as a NOT gate. So that means in this case, when there is input is given, we are getting no output is there. When input is not given, we are getting the outputs. That means, so in some of the digital devices, when we want to inverse the output value, in that case the NOT gate that is preferred over here. So NOT gate that is represented like this. So this NOT that must be over here, that is important here. So NOT that will be there, which clearly show that the output that is equals to inverse to the input value. So again, so this is a Boolean expression over here. Now again, in order to maintain the truth table. So in the truth table, if this is a A input and that is equals to output over here, when we are giving 0 to the input value, so in the output we are getting 1. And when no 1 is given, so we are getting no output value. So this is a truth table for the NOT gate. So in the NOT gate, that means when the 0 is given, so 1 is there, and when the 1 is given, input is given, so 0 will be there. So there is no output. So such kind of gate, that is known as a NOT gate. And the expression is that y equals to output, that is equals to A inverse. So that means inverse to the input, we are getting the output value over here. So this gate is known as a NOT gate. Now next is known as a NAND gate. So that is a NAND gate means it clearly shows that AND means that is a combination of two gates, NOT and AND gate. So this is known as a NAND gate. So in that case, that is a combination of two gates. One is and second one is a NOT gate. So firstly, it is a AND, then there is a NOT gate. So how we can represent that? It as, we know that that is a representation of AND gate. So two outputs are there, Y, A and B. So this is the AND gate over here. And the NOT gate is so that is a NOT gate. Now we want to combine these two gates. So what is the difference between these two here? The multiplication of these two inputs are done, and in the NOT gate, to the input we are getting inverse to the output value. And when we combine these two gates, so these two gates that can be combined like that. So this is the input value, and in the output we will get this gate. So here is the output over here. So this is a representation of this gate, NAND gate, and Y that will be equals to inverse of this. So that will be the output value over here. So that is a NAND gate. So that means a Y that will be equals to inverse of this. So Boolean expression that will be equals to multiplication of this. Then after that we will give the inverse of the output value. So how we can design this truth table? So the truth table that can be designed like this. So now it's truth table. And the output is, now in the AND gate, when 1 is there and 0 is here. So what is the value over here? Now if this is the output for the AND gate. Now for the AND gate, what will we get? When 1 is here, 0 is here, we will get 0 over here. So that is for the AND gate. Now, but for the NAND gate, that means when there is a combination of AND NOT gate. So now reciprocal of this 0, that will be equals to 1 over here. So in this case, we are getting the output value over here. Now again, when 0 is here, 1 is here, again, there is no output value. But again, we will have to done reciprocal of this, then 1 will be there. Again, when 1 is here, what is the output over here? 1 is again, but here we will get the 0 value. Zero is there, so there is no output, but we will get output over here. So this is a truth table for, now that is for the AND gate, output for AND gate only, and that is the output for NAND gate. So that means when we combine the AND gate and the NOT gate, so reciprocal to this output value, we will get output over here. So that means when there is no output, we are getting output over here. Again, when there is no output, then again output is present over here. So that means reciprocal of this. So when we want to invert the AND gate, in that case, combination of AND gate and NOT gate that is used over here. So this is the truth table for NAND gate. So in the NAND gate, so that is the truth table. How we are getting this truth table? Here Y that is equals to AB inverse is done. So inverse that is plotted over here. So that is the NAND gate. Now next is the NOR gate. Now what is a NOR over here? So NOR gate, that is a combination of OR and NOT gate. So OR and NOT gate, they are combined over here in order to get the output value over here. Now how we can combine these two gates? Now that is a OR gate. A or B. And this is the NOT gate. Now when these two are combined with each other, so in that case, so this NOT will be present over here. So that will be the Boolean expression. So that means A plus B, that is equals to Y, A and B, A or B and NOR is there. So that is a NOT. It will represent the NOT gate over here. So this is known as a NOR gate. So NOR gate, that is a combination of OR and NOT. Now how we can plot it its truth table. So the truth table of this, that can be represented like this. A or B, and that is for NOR gate. Now when 1 is there, 0 is here. So in the OR gate, we are getting the output value. But in this case, reciprocal to 1, that will be equals to 0. So that is the OR gate. NOR gate, this is for the OR gate, and that is the NOR gate. Now when 0 is here, 1 is here, again we are getting 1 over here, again reciprocal to this, that will be equals to 0. When 0 is there, no output, but we are getting a output value over here. And no output is there. So this is a truth table for NOR gate, and that is for the OR gate. So that means when we want to reciprocal the output of OR gate, the OR gate that can be combined with the NOR gate. So combination of OR and NOR gate, that will be done in order to give the reciprocal to the output value for the OR gate. So this is known as the NOR gate. So NOR gate, that is a combination of OR and NOT gate. So reciprocal, that means this output value, that is reciprocal to the OR gate. Now next is the exclusive OR gate or the XOR gate. Now what does it mean? Okay. Now XOR gate, that is the output of two inputs. XOR gate attains the state 1 if one adds only input and attains the states 1. So what does it mean? That means, so this is known as, so here reciprocal to one input is done, then they are get added up. So such type of gate, they are known as the XOR gate or the exclusive OR gate, and this is a signal or the representation of this XOR gate. Now how we can represent this signal? That means if this is the OR gate and the input are given over here, so in the output value, we are taking reciprocal to over here. So when the reciprocals are done, so that means XOR gate is represented like this, and its expression, that is equals to A plus B, and which is equals to inverse of A into B inverse, like, so that can be represented over here. So this is the output value over here, and this is a truth table of XOR gate. So what does that mean? Means in the XOR gate, when A's input is 0 and B is also 0, and how we are getting 0 over here? So that means if input A is 0, so that means this is 0, this is 1 plus, firstly we will draw its truth table. So the truth table of this, that can be explained like this. Okay, now this is output value. Now when this is 0 and that is also 0. So in this case, this is 0 means that is 1. And that is 0 and that is 1. Again, we will get over here, 0 will be there. So when this is 1 and that is 0, so in that case, that means when this is 1 and that is 0, again we will get a 1 over here. Same in a similar way, when A is 0 and B is 1, then we will get 1 over here. Now when A is 1 and B is 1, again in the output value we will get 0 over here. So that means these kind of gates are known as the exclusive gate. That means we are getting only output when the input is present only at the one port. So here we can clearly see that when the input is present on the one port, we are getting the only output value that can be attained over here. When the input is present on the both of the port, we are getting no output is there. So that's why this is known as the exclusive OR gate. So next is the exclusive NOR gate. So this is also known as the XNOR gate. So that is known as XNOR gate. Exclusive NOR gate means now in the XNOR gate, the output is in the state 1 when both inputs are the same. That means when both inputs are either 0, then we will get the output. When both inputs are 1, then we will get the output. So that means when both of the inputs are same, so this is an important term over here. When the both inputs are same, then we will get the output. And its Boolean expression that is like this. That means if that is equal to AB plus A inverse B inverse. So that is the Boolean expression for the XNOR gate. And that is how this output value is present. So that is a combination of XOR plus NOT gate. So this is a combination of XOR plus NOT gate. So this is a XOR gate and that is a NOT gate. So that means now when we are getting a 0 on both of them, inputs are same, then we will get output. Again here the inputs are not same, then we will get no output is there. Again when in this case these inputs are not same, we are giving input only to the one port, then output will be 0 over here. Again 1 1, that means the input is given on both of the port and the both of port have the same value, then in that case we are getting the output value. So such kind of gate that is known as the exclusive NOR gate. So exclusive NOR gate, that is a combination of XOR and the NOT gate. So that means in this case, when we want to inverse the input of the NOR gate or the XOR gate. So XOR gate, its output value that can be inverses by combining this with the NOT gate. So such kind of gate that is known as the XNOR gate. So this is about the logical gates and how we can convert the analog signals to the digital signals. So by using this different kind of logical gates, we can get the output value. So depending upon our requirement, the different gates like OR gate, AND gate, NAND gate, NOT gate, exclusive OR gate and exclusive NOR gate. So they can be implemented or they can be used in the digital devices. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.